Hey guys, this is our snow day lecture for Wednesday. Um, I'm sitting here at home with my cat, enjoying my nice view of a snowy yard. I hope you guys are enjoying your day off in quotation marks. So anyway, what we're going to go over today is factoring trinomials first, and we're going to do simple trinomials without a coefficient on the lead term. And then on 5.3, we're going to do factors with trinomials with the leading term other than 1, so with a leading coefficient. So recall in the last section we went over factoring monomials, and so this is factoring polynomials of this type with a single term and factoring it into multiple factors and different factorizations, and in this section we'll be factoring things like this guy here, right? It'll be things where we'll be factoring things like this guy down here in the red box, right, where we don't have a common term we don't have a common factor in each term, and so we have to factor them in different ways. And so, keep in mind that both these methods of factorization can be put together. And for example, this one on top here, we could factor an x out, and then we would have 3x squared plus 2x plus 5, and then we could factor this inner polynomial one more time using the method that we're about to learn. Okay, so when we're talking about polynomials, at least in this section, they're all of this form right here that you see. Right, x squared plus bx plus c. So there's no coefficient out in front of the x. We have a simple b attached to the x term in the middle and a constant c. Right, and so for this example, our b would equal 2, right, this guy right here, and our c would equal 4. So now let's go ahead and sort of illustrate this what we're about to do by multiplying out several factorizations, right? And so what you see on the left here, these are all what we call factorizations of a polynomial, right? What you see over here on the left, this is going to be the end product of what you're going to learn how to do in this section. So let's go ahead and FOIL these guys out and see what they look like here. Well, this one is x squared plus 2x plus x plus 2, right? And that's using our little FOIL method. So this is actually equal to, of course, x squared plus 3x plus 2. This guy here, this is equal to x squared, let's see now, plus 5 minus 4, so we'll have plus x minus 20. And this guy here, we have x squared minus 7x and plus 6. Okay, so one thing that we want you to notice in each and every one of these expansions, we want you to notice that the coefficient of this middle term, right, each middle term here, this coefficient is just a 1 right in here. This one is a -7. And so notice that the coefficient in each of these is the sum of the second terms in each binomial. And so that's the first thing to pay attention to here, right? So when we factor out a trinomial of this form, we say, okay, the two second terms in each binomial are going to sum to equal this middle coefficient. Okay, so the other thing that we want to notice, maybe I'll do this in blue, the other thing that we want to notice is that the constant terms, this guy here, 2, -20, and +6, these are actually the products of these second terms in the binomials. Right? And so we can use this to inform us on how to factor these things out. And so when we're given something like this, we can reverse this operation and go to the factored form, right? By simply finding the right combinations for the b and the c right here. Okay, so now let's go over the different cases, right? And so the cases, we can see in our general form up here, x squared plus bx plus c, there's a couple different cases that could happen, right? We could have a -c, or we could have a -b, or some other combinations of those. So we deal with the factoring in those situations in a little bit different ways. So if the constant term is positive, and by the constant term, I do mean, oops, not a, I do mean x squared plus bx plus c. The constant term is this guy here, is c. So I went ahead and rewrote our little notes up here. And so let's sort of consider this with a real trinomial here. So if we factor this trinomial, x squared plus 7x plus 10, that's going to factor into something that looks like this in a general form, right? And we're going to have factors p and q as our constant terms in each binomial. So as we sort of found out on the last step, these are our options for p and q. This is going to dictate what we use for p and q, right? So we need a p and q. Uh-oh, there goes my dog. Hold on, I'll have to pause it. So where were we? So anyway, we were discussing our p's and q's. So anyway, what we want to find, right? Our factorization will take this general form. And what we want to find is a p and q whose product is 10 and whose sum is 7. Right? That's what we would want to find in order to factor this guy out, right? And so just so we know what the factorization for this guy is, if we were to do this out, our p and q would be, let's see now, x plus and plus. So our p and q would be 5 and 2. Right? And you'll find out why that's true in just a second. We'll go over the operations on how to find that 5 and 2. Honestly, you can probably just, for simpler factors, you can just look at this definition and kind of figure it out after a little bit of thought. So let's go on to an example. So for the first example, we're going to use this guy, x squared plus 5x plus 6. So this is going to factor into a general form that looks like this, right? We can even come down here and start writing our general form, right? If we want to sort of make our end goal really obvious, right? X plus and x plus, right? All we need to do is find p and q that go in here. Okay, so what we want is a p and q that multiply to 6 and that sum to 5. And so first, we're going to consider our options, right? We know that p and q must sum to 6. And so we're going to create a little table. On the left side of the table, we're going to list pair factors of 6. On the right side of the table, we're going to list what those factors sum to. And we're going to stop when we reach factors that sum to 5. You see down here I've written, we want 5, right? And so what are the factors of 6? Well, let's see now. We have 6 and 1. That sums to 7. So we're not looking for that. We have 1 and 6, but that's the same thing, right? It just sums to 7. Oh, we also have 2 and 3. And 2 plus 3 is equal to 5. And so ding, 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 we have our answer, right? We have our p and q now. We know that they multiply to 6 and that they sum to 5. So it's good. Okay, what were our factors? 2 and 3. Boom, 2, boom, 3. And that's it. There's our answer, right? And so all we do, let's come up here to the original. We look at this guy and we say, what are all the pair factors of that guy, right? In our general form, in our x squared plus bx plus c, we look for all the pair factors of c. Then we go ahead and complete that table by filling in the right side, and we look for pair factors that sum to b. Sum to this guy. Okay, and so we found that in 2 and 3, so those were our answer, our results, right? And now if we multiply this guy back out, we get x squared plus 3x plus 2x plus 6. This is equal to x squared plus 5x plus 6. Let's go up to our original polynomial. We have a match. That means that this is the correct answer. Okay, so I think we already went over this in the last one, but in general, right, in our general form, when we don't look at a specific example, this is what we're looking for, right? All we need to do to find factors, right, this is always equal to some set of factors, x plus and x plus, right, p and q. Right, we always just look for p and q such that this is true and this is true. Now, we're going to go over this later in the chapter, but keep in mind that this This might change a little bit. I mean, it's the same basic concept, but your signs might change inside of your factors here when the signs of these change in the general form. And so we'll learn about that later. But when both those signs are positive, it's a pretty easy case, and all you need to do is list the factors of C and find which of those factors sum to B. Okay, so let's do an example of this guy real quick. Suppose we had y squared minus 8y plus 12. So our C is equal to 12, and our B is equal to negative 8, right? So that means we have to find P and Q such that P and Q multiply to 12 and PQ sum to negative 8. We can do that, right? Okay, so so keep in mind here that because we have a negative in the middle, a positive out here, right? P and Q, since their product is a positive, right? P has to be negative and Q has to be negative, or they both have to be positive, right? That's the only option, right? It's either, to get a positive 12, you can have a 3 times a negative 3 times a negative 4 equaling 12, or you could have a 3 times 4 equaling 12. And so it's like the two factors have to be both negative or both positive. Since we have a negative number on the middle term, we know they both have to be negative, right? Because they have to sum to a negative number. And if you have two positive numbers, that's not possible. Okay, so let's go ahead and create our table. All right, we're looking at pair factors of 12, and they're both negative, right? And so let's see now, negative 1 and 12 and negative 12. What does that sum to? Well, that sums to negative 13, so that's not what we want. What else? Well, there is 2 and 6. Actually, why don't we do 3 and 4 first, just so we don't get our answer right away. Negative 3 and negative 4. Well, those sum to negative 7. That's not what we want either, right? We want a negative 8. So how about negative 2 and negative 6? Those sum to a negative 8, and ding, 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 we have our answer. So our factors are, okay, let's just go ahead and rewrite the problem real quick. Whoops. Y squared minus 8y plus 12, right? That's just equal to x minus 2 and x minus 6. That's it. We can go through and check our work again to make sure it's correct. I'll let you guys do that on your own. So once again, remember what we did there. We went ahead and we identified our C and our B when we created a table. We listed the pair factors of C, and we found two pair factors that summed to the B that we had, right? We used negative factors because the B was negative. Okay, so how about a different case? What happens when the constant is negative, right? And so in the case where the constant's negative, when we have something that looks like this, x squared plus bx, we have like a negative c, right? When this sign is negative, then we have two options, right? Our factors are going to look like this. It's either going to be x plus p, x minus q, or x minus p, x plus q, right? In order to get, we want two numbers whose product is going to be a negative c, which means one of those numbers has to be negative. Okay, so now we kind of have to analyze the trinomial as to which one of these options we use, right? So what dictates, right, if we have, say we have a p times a q, which is equal to our c, right? Suppose we have that, and then we say, okay, we're looking for a p plus a q, which is equal to b. Now, which one of those factors is going to be attached to the negative, right? And which one's going to be attached to the positive? Well, that's dictated by the sign of the middle term, right? That's all dictated by this, right? So we know that we have something with positive and negative in our factorization. Which one is the positive and which one is the negative? Well, if the b is positive in our trinomial, then the larger factor is attached to the positive. If the b is negative, then the larger factor is the negative factor, right? And that's because these have to sum to b. If b is negative, obviously the larger part of the sum has to be negative. Otherwise, it wouldn't work. Okay, so let's go ahead and try one of these guys out, right? So right away, let's see now, we have a negative back here, so we can say that our factor is going to look like this: x plus in parentheses and x minus in parentheses, right? We just need to find values for here. Okay, so the 20 is negative and the 8 is also negative. That means that our larger factors get the negatives attached to them, and I'll show you what I mean by that over here when we start listing our factors. So let's think about factors of 20. Well, so 1 and 20 are factors of 20, right? Which one of those does the negative get attached to? It's got to be the 20 because that's the larger one. So we're going to say the factors of negative 20 are 1 and negative 20. That sums to negative 19. That's not what we're looking for. Okay, 2 and negative 10. Well, that sums to negative 8. Hey, look at that. That's exactly what we're looking for, right? So for just a quick illustration, you can see why that wouldn't work if we attached the negative to the other factor, right? If we said, well, the factors are negative 2 and positive 10, then we end up with a positive 8. And we know that we didn't have that, right? We already saw that the sign was negative over here. And so, this is not even worth analyzing. Okay, so we found our two factors that work, right? So now all we need to do is throw them into our factorization, right? We already knew that the negative was attached to the 10 and the positive to the 2. So that's it. That's our factorization. Okay, so how about we do the same thing with this guy? T squared minus 24 plus 5t. Well, first of all, let's rewrite it into ascending form. Plus 5t minus 24, okay? C is equal to negative 24, and B is equal to 5. So, since our 24 is negative, we can go ahead and start writing our factors out right away, right? X minus something and X plus something. Okay, what do we fill that in with? Well, let's see now. We have 24. Right? Our middle term is a positive, so we know that the larger factor is going to be positive, right? So let's go ahead and start writing out our table, right? Pair factors, right? Sums. We want 5. Okay, so pair factors of 24, right? The middle term is positive, so we attach the positive to the larger factor. Okay, so 24 is 12 times 2, right? So let's see now, negative 2 and positive 12. Well, that sums to a positive 10, so that's not what we're looking for. Let's see now. Suppose we had a 6 and a 4, right? Suppose we had a negative 4 and a positive 6. Well, that sums to 2, and that is not what we're looking for either. So now we're going to consider, well, let's see now, let's consider another factor. Let's just go all the way down the list, right? So what about 1 and 24? Negative 1, positive 24, right? This ends us up at 23. That's not it either. What about 8 and 3? Negative 3, positive 8. Ding, 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 that guy sums to 5, and we have our factors, right? Negative 3 and positive 8. 3, 8, and we're good, okay? I should say, we're good after we check our work, which I'm sure you guys are all doing at home because you're so studious. Okay, so now we have a little bit of a different example, right? So this example is weird because our constant term actually has a variable in it. What are we going to do with that? Well, we're just going to treat it just like the constant term is, So we're going to say C is equal to negative 21b squared. And B is equal to 4b. Why not 4ab? Well, because a is our variable term that we have our square on. right? We could actually turn this guy all the way around and factor it sort of by the b's instead of the a's, but we're not going to do that today. So we have our c, and so in our table, we're going to do the same table that we always do, right? Pair factors of negative 21b squared. And we want to sum to 4b, right? And so what do pair factors of negative 21b squared look like? Well, they look like they have a b in each one, and then the rest is just factors of 21, right? So so let's see now. Let's analyze what our middle term is so we know which factor to attach the negative or the positive to. Well, our middle term is a positive 4b. So that means that we attach the positive term to the larger factor. Okay, so let's see now. What are the factors of 21? Well, there's 1 and 21, right? So negative 1 and 21. Clearly that's not it because it sums to 20. Oh, I should say 1b and 21b, and that sums to 20b squared, negative 20b squared. Sorry, positive. Yes. No. Sorry, I'm screwing myself up here. So back it up. That does not sum to 20b squared. I am making a classic mistake there. So what does this sum to? 20b, right? Not 21b squared. The product is negative 21b squared, not the sum. Okay, so I'm tired of blabbering. So the next factors we'll consider are 7 and 3. We're going to attach the negative to the smaller factor because we want an overall positive sum. So negative 3b and 7b are our next factors, and the results of that are 4b. That sums to 4b. That's exactly what we're looking for. So we know that these are our factors. So let's come on down here. What's this guy going to look like? Well, it's going to be a, right, plus and minus. We already know that's the case because our constant term is a negative. Plus and minus. And our negative is 3b. Our positive is 7b. Okay, when we multiply that guy out, we should get the original polynomial. Yay. All right, so, oh, is that another example? No. Okay, so that's the last example of those. What about prime polynomials? How do we know when one of these is as broken down as it's going to get, in this class at least? Well, let's consider what we're doing here, right? And there are a few tricks that we can learn later on how to do this kind of the simple way, but right now we're just going to consider our options, right? And so for this particular polynomial, we want a p and q that equals 5 and a p and q that sums to negative 1. Let's create a factor table, right? Pairs and sums. We want negative 1, right? The 5 is positive, so they either both have to be negative or both have to be positive. The x in the middle is negative, so that means they both have to be negative. Well, what are the factors of 5? Well, it is 1 and 5, or 5 and 1, right? Neither of those is going to sum to negative 1 ever. So we have a prime polynomial, right? When there are no options that work, we're safe to call it prime. Okay, what do we mean? Let's go over just something really quick called factoring completely. Oh, hey, I spelled factoring wrong. That's something that I've been doing a lot in this lecture. So anyway, when we say factor completely, or even when we just say factor, we mean factor completely. And so this example is a lot like kind of the one that I showed you on the first page, where we factored out an x first, and then we considered the polynomial inside. So with this one, we're going to say, let's factor out whatever we can from each term. That includes variables and constants, and then we'll go from there. Each of these terms can be divided by 2, and we have a 2 coefficient. We also have a negative sign that we don't like. So what we're going to do is factor out a negative 2x. Okay, and that leaves us with x squared minus 10x plus 25. Okay, So now that we've factored out the negative 2x, we're going to go about our normal operations for factoring out this middle term, right? Where our c is equal to 25 and our b is equal to negative 10, right? So let's go ahead and throw together our factor table. So factors of 25 and sums. We want negative 10. Okay, and so let's see now, what's our final answer going to look like? We can pick that out right away just based on the signs of our b and our c. So our final answer is going to look like negative 2x on the outside. That's going to remain the same. And on the inside, we're going to have x. So let's see now. We have a positive c term. So we know that both of our constants have to be positive or both have to be negative. We have a negative middle term, which tells us they both have to be negative, right? And so x minus something, and then another x minus something. Okay, what are the factors of 25? Well, we have let's see now, we have negative 1 and negative 25. That sums to negative 26. That's not what we want. And we also have, hey, look at this, negative 5 and negative 5. That sums to negative 10. Ding, we got what we want. Negative 5, negative 5. We can rewrite this as negative 2x, x minus 5 squared. Cha-ching. Okay, so when we say to factor completely, it's whenever you have an x in every term, you know you can factor out a variable, right? When your leading term, like in this case, when our leading term had a coefficient out front, we also want to try and factor that. When our leading term has a negative out front, we definitely want to factor that, because that creates a very confusing situation. Okay, we're going to learn a little bit more about how to handle these problems with the coefficients out front in the next chapter. All right, so moving on. Okay, so in this one, we're going to go over factoring trinomials in a little bit different form. So this was the form that we used last chapter, right? The only thing that's different about the form we're using in this chapter is this little coefficient out here, this little a out here. That can actually make things quite a bit harder. You know, I'm pretty quick at factoring stuff without a coefficient on the lead term, but it takes me a decent amount of guess and check to figure out how to factor these guys with the a's or with the constant leading term. So, and just a little bit of advice as you guys are kind of watching over this factoring stuff is definitely along the lines of it's kind of like it's a hard curve, I guess I should say. It's tough stuff to learn for a lot of people. So don't slack on your homework and your studying during this, because we're going to be doing a whole lot more factoring in this class. This isn't one of those concepts that kind of just comes and goes. This is one of the concepts that you'll be using in this class, in 105, in 151, and calculus and beyond if you want to go that far. So, just a fair warning, this is a very important chapter. So pay close attention and don't be afraid to do some extra examples on your own just for practice. All right, so let's go ahead and start this guy out. So like I said before, we're dealing with terms with a different a in front, right? What does that do to your factorization? Well, as you can see down here, this is what a factorized version of this looks like, right? The only difference between this factorization and the ones that we did last chapter are that we have little coefficients up here that we have to consider. Okay, so when we FOIL this set of binomials out, notice that this is what we get, right? FOIL, FOIL, FOIL. Okay, so and so we can see from this consideration up here that the coefficients, right, that our first terms here, the coefficients 2 and 3 must multiply to 6, right? And so let's see now, and so they have to multiply to a, basically, is what we're saying in our general form. Let's also notice that the product of the outer terms and the product of the inner terms must sum to 23, right? And so this is the product of the outer terms. This is the product of the inner terms, excuse me. And we'll just write what all this is in simplified form. X squared plus, oops, not 8x. I just said that was supposed to be something else. So that is 23x plus 20, right? And so those two, the I and the O, must sum to 23x, right? And so we'll notice about the L, right? The last two terms sum to equal the L term. Okay, so in general, and I realize this might confuse the heck out of some of you guys, so if this looks super confusing, don't even pay attention to it, but this is what our general form looks like, right? And I filled in our coefficients with just a D and an E to represent, you know, like in this one, our D would be 2 and our E would be 3. And so what we're looking for in these examples are a D and an E such that they equal the leading term, right? And when we multiply dx by q and add it to ex times p, we get the middle x term. And then, of course, p times q equals constant term. Like I said, if this is super confusing, don't even worry about writing it down. That's just my own sort of explanation that makes sense to me. But, you know, I have a different background than you guys so far. So let's go ahead and start on this first guy. All right. So let's start by seeing if we can factor anything out, right? Do the terms have anything in common? Well, no, they don't. So let's consider, let me just, okay. So let's first just consider what our factors of the first term can be, right? And so let's go ahead and write out what our answer is going to look like first. So it's going to be 2x's, right? Oops. And what I forgot to do, which you should always do when you have a coefficient in there, is leave room for the coefficients on the x's, right? So we have a negative 8, and that means we're going to have a positive and a negative in our factorization, right? We have a negative 10, which means well, that doesn't exactly mean the same thing now since we have 3's and 1's. So what we need, right, is for this term and this term to multiply to 3. Well, so we only have two options, right? Usually we'd have more and we'd have to do a couple of different guess and check methods, but since 3 is prime, we only have two options, right? 3 and 1. Ooh, but I should actually erase that. Right, let's go ahead and erase that. Come on, work. Let's go ahead and actually just erase our signs, and that will allow us to keep the 3 and the 1, right? Because the 3 and the 1 affect things in the way they do, we can't really throw the signs out there and assume that we know what's going to happen yet. So what we're going to do, we're going to list some factors of 8, right? Factors. Okay, so now we're going to go ahead and consider the factors of 8, and sort of this is my own method of doing this. We're going to consider the factors of 8, and over here I'm going to sum them in the two different possible ways that they will be summed, right? And so we consider the first factors of negative 8. Let's say they are negative 1 and 8, right? What are the two ways that those could sum in our final product? Well, they could sum by saying, well, 3 times 1 plus 1 times the other. Or you could switch those around, and so we can either say 3 times the negative 1 plus 8, or we can say 3 times the 8 plus the negative 1, right? And so it's either negative 3 plus 8, or it's 24 minus 1, right? And so this one sums to 23, and this guy sums to 5. Okay, so let's see now. Well, and neither of these guys is what we're looking for, right? And so let's find two more factors of 8. Let's try 4 and 2. Okay, and actually, why don't we try this? Let's try this with a -8 and a +1 instead of, just so we can consider all the factors, right? And so 3 times -8 is -24. 1 times 1 is just 1. And this is -23. And and 1 times -8 is -8. And 3 times 1 is 3. That equals 5. Hey, look at that. It's the same. Okay. Oh, -5. Okay, so now let's consider some other factors of 8. How about we say -2 and 4? Okay, 3 times -2 is -6. If we added that to 1 positive 4, we would get -2. If we said 1 times -2 plus 3 times 4, hey, look at that. We get a 10. That's what we're looking for, right? That's exactly what we're looking for. And so we got those results when we multiplied the -2 by 1 and the 4 by 3. Okay, so what does that mean? That means that we can fill out the rest of our sum, right? And so our factors are going to be, our constants in our factors are going to be -2 and 4, right? Which one do we assign to which factor? Well, over here, we chose the option where we multiplied 4 by 3. So the 4 has to go over here in the opposite factor. Why? Because when we FOIL it out, that's one of the multiplications that we carry out, 3x times 4, right? And then this -2 goes over here. Why is that? Well, because we needed to carry out this 1 times -2 in order to match this factor, right? And so it's a little bit different. And the only thing that I did kind of differently is that, we have to consider more options for our sums, right? The thing that was really easy about this problem is that we had a prime number for our coefficient. When that's not the case, then it can become pretty ugly. You can end up with just, 3 or 4 different columns sort of over here all lined up trying to sum them all out. It's pretty tedious. So, speaking of slightly tedious, let's get into all these factoring examples. So, here we go. We have a factor here. We have not a prime number out here in front, and so we have to consider 2 options for our ending factors. So it either has to look like this, right? Our factors of 10 are 1 times 10 and 5 times 2. So we either have to have a 10x and then a 1x, right? Or our factors would be a 5x and a 3x. Oops, no, not 3, 2. What am I doing? Sorry, a 2x. Okay, and so we know it's one of these two. We just need to find out which one it is and which options we're using, right? So our C is equal to 7. All right, so let's start building our table out here. So let's say pairs. Right? We have a positive 7. We have a positive middle term as well. This tells us that, the positive 7 tells us that both of these have to be negative or both have to be positive. The positive 37, that actually tells us that they're both positive. So we can go ahead and fill that in. Okay, so we have the pairs. We're going to say sum, right? And I'll just say, let's see now, how about let's try this side in the first couple of columns. So I'm going to say 10 and 1, right? Or sum 1 and 10. In our next column, I'm going to say sum 5 and 2, or sum 2 and 5. Okay, so pairs of 7. Luckily, 7's prime, so we only have to consider 2 pairs. 1 and 7, and 7 and 1. And we really only need to consider 7 and 1 just because these guys swap back and forth. We'll consider all of them all in one. So 7 and 1. Okay, so that gives us 70 plus 1. Well, that's not it, right? Because we're looking for 37. Okay, and so this one gives us 7 plus 10. That's not it, because that gives us 17. This one, 5 times 7, that gives us 35 plus 2 times 1. Aha! That gives us a 2, and we have a 37. Ding, ding, ding. Victory. What would have the other one been? Well, that would have been 14, 2 times 7 plus 5, which would have been 19, and that would have been bad. Okay, so we don't need to worry about that, though, because we already found our options, right? So our options, the one that worked, was with the 5 and the 2, with the 5 being applied to the 7 and the 2 being applied to the 1, right? So it's not this guy. We can cross that guy out. It's this guy. The 5 was applied to the 7, so the 7 goes in the opposite factor. And the 1 goes in the opposite of the 2. Right? Go ahead and multiply this guy out at home and check my work. I could be wrong, as you guys know I am frequently, so you should always check my work. Okay. Oh boy, let me stretch out. All right, this is a long video. Okay, so let's try another example. So this one, when we go through and check for common factors to begin with, we can see that this contains a few common factors. All right, what are those factors? Well, you can work this out at home on your own, but well, actually, maybe I'll just do it here in the video. So this one is 4, right, times 6 times x cubed, right? The middle term is, what is this? This is 4 times 19 x squared. This last one is 4 times 10x, right? What are the common terms, right? We have 1x in each, and we have 1 4 in each. So out front we can write 4x, and then complete our polynomial in here, right? By writing our remaining terms, 6x squared, right, minus 19x, and plus 10. Okay, so we've done our first factor. Now let's move on to the second one, right? Our 6 is not prime. Well, that's bad news, so that means we have to consider more than one option, right? And so our factors of 6 are, we either can say 2 and 3, or we can say 1 and 6. So our answer is going to be 6x and a single x, or we're going to have 2x and 3x. Okay, so so we have a positive number for C, which tells us that these signs must be either both positive or both negative. We have a negative number in the middle, which tells us that they're both negative. Okay, so we can go ahead and fill that guy out. Now let's go ahead and fill out our table. So we have some things to consider. Pairs, right? Sum, 6 and 1, right? Sum, 1 and 6. Sum, 2 and 3. And of course, 3 and 2. Okay, so we're looking for pairs of multiples of 10. Well, as far as multiples of 10 go, there are only 2 different factorizations of 10. That's 1 and 10 and 2 and 5. So first, let's consider 1 and 10. We know that they're both negative, right? Negative 1, negative 10. Negative 1 times 6 is negative 6. Then we have a negative 10, and we get negative 16, right? Oh, and keep in mind, what do we want, right? What do we want? We want something that sums to this, right? Want negative 19. Okay, so what if we enter this negative 1, negative 10 pair into the next one? Well, we get negative 1 and negative 60, right? That gives us a negative 61. That's not what we want. Okay, negative 2 and negative 30, negative 32. That's not what we want. Okay, negative 1 times 3, which is negative 3, and negative 10 times 2, which is negative 20. That gives us a negative 23, and that's not what we want. Okay, so it doesn't look like 1 and 10 are going to work. Let's try the other pairs, right? 2 and 5. Negative 2, negative 5. Okay, so negative 2 times 6 is going to be negative 4. Negative 5 times 1 is negative 5. Negative 9, that doesn't work. Okay, 1 times negative 2. 6 times negative 5, negative 30. That's going to give us negative 32. We don't want that. Negative 2 times 2, which is negative 4, and negative 5 times 3, negative 15. Look at that. We got a negative 19. We have a winner. Ding, 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 ding. All right. So what was that winner under? Well, that was under the sum 2 and 3. So it's not going to be this guy. We can cross this guy out. That's not going to be our answer. It's going to be the answer corresponding to 2 and 3. Well, what order did we multiply those guys in? So we multiplied the 2 by the negative 2 in order to get our sum. So that is going to go here, right? Because we need to multiply this 2 by this 2, right? Our other term was going to be 5. We need to put that over here because we need to multiply the 5 by the 3, because that's how we did it here, right? The 3 and the 2. Okay, and so that's it. This is our final answer down here. Let me erase this stuff. This is our final answer. And so you can see what we did. First, we factored out anything we could. Oh, final answer. Sorry, I almost forgot the 4x. This is something that I forget a lot, so be careful yourselves, right? 4x is part of that final factorization. Okay, let's do another example. We got a few more of these to go. Okay, so how about we tackle this guy? Well, first things first, let's write this in ascending order. Negative 3x squared plus 10x plus 8. Okay, in this, our a is equal to negative 3, right, which we don't like. So what we're actually going to do, this is something that we never like, right? And specifically this here. We don't like that negative out there, because then that means that we're going to have to break up our factors with a negative and a positive out front of the x's, and that causes all sorts of confusion. So what we do is we factor out a negative from the entire polynomial and then continue, right? And so we factor out a negative, right, negative 1, and we end up with 3x squared minus 10x minus 8. Right, and so now we continue to factorize this guy in the middle, and then we remember to attach the negative at the very end. So what are our options here? 3 is prime, our a is prime, so we know that our answer is just going to look like this, 3x and x. 8 is a negative, right? So that means that one of these is positive and one is negative. We don't know which one yet. The middle is negative as well, right? Which would tell us that the negative is probably attached to the larger factor. But since we have these we have this 3 and the 1 up here, that changes things up a little bit. So we're going to have to consider all factors. So first things first, let's say pair factors of 8. Right, what we're considering here is 3 and 1, or 1 and 3. Okay, so what are the pair factors of negative 8? Well, we have negative 1 and positive 8. So what happens if we enter that here? We have a negative 3 plus 8. That gives us a positive 5. Oh, and I'll write up here above the sums, we want a negative 10. Okay, so that's not going to work. Negative 1 times 1 is negative 1. 8 times 3 is 24. This is equal to a 23, and that doesn't work. Okay, so let's consider the other pairwise factor. So let's consider negative 8 and 1. Right, which these are going to give us some similar answers. So negative 8 and 1, well, this gives us negative 24 plus 1, so negative 23. And so you can see we actually don't need to do this one if we can just see, if we're looking for the opposite answer, if we wanted negative 23 and we got positive 23 up here, then we'd complete this next line, but we don't really need to because we don't need a negative 5, and that's what the next one's going to give us. So we can consider the other pair factors of 8, 2 and 4. So how about trying negative 2 and positive 4? Well, let's run through our little sums. So negative 2 times 3 is going to be negative 6 plus 4 is negative 2. Negative 2 times 1 is negative 2. And 4 times 3 is going to be 12. 12. What does that equal? Well, that equals a positive 10. Oh, check this out. It's a positive 10, not a negative 10, though. We want a negative 10. And as we saw up here, all we need to do is sort of switch things around to get the negative version of that 10, right? So we attach the negative to the 4 and the 2 to the positive, right? And then we, on this very first one, negative 4 times 3 is negative 12, plus 2 times 1, which is 2, equals negative 10, and we have our winner. Okay, so now we know that our two factors were negative 4 and 2. Oops, let's not forget this negative up here that we usually forget. And we know the order that they go in, right? And so the negative 4 must multiply by the 3, and so we put it back here, right? Because when we FOIL out, we're going to multiply the 3 by the 4. The 2 must multiply by the single x, right? And so we're going to put that here, plus 2. Right? We can multiply this guy out and check our work at home. All right, let's try another one here. And keep in mind, guys, you guys might be looking at this at home saying, like, what the heck is going on? Or maybe I'm doing a great job here and you guys know everything that's going on and you're ahead of me on all this. But keep in mind that these are definitely the type of problems that I'll be doing extra examples for, just because factoring can get super weird, especially when we do like factoring by grouping and stuff like that. Okay, so what if we wanted to factor this guy? Let's go through this process one more time. What do we look like down here? What does our answer look like? Well, so our options are, since 6 is not prime, we have to break this up into 2, right? The factors of 6 are 6 and 1, or 2 times 3. So we either have 6x and a single x, or we have 2x times 3x something. All right, so we have negative 28s squared for our c value. That tells us that one of these has to be negative and one has to be positive, but we don't know which yet. We're gonna figure that out by filling out our table. All right, okay, so we want pair factors of negative 28s squared. Okay, we want those to sum. We want negative 13s for our sum. Right, and so our options, we either sum 2, 6, and 1, sum to 1 and 6, sum to 2 and 3, or finally they might sum to 3 and 2, sum with 3 and 2. Okay, so, oh boy, so where do we start with this guy? pair factors of a negative 28. Well, oh boy. Why don't we just start with, how about we just start with 2 and 14? Okay, so why don't we say negative 2 and positive 14? All right, let's begin the tedium here. So negative 2 times 6 is negative 12 plus 14. Well, that's a positive 2. That's not it. Okay, negative 2 times 1 is negative 2. 14 times 6. Hold on, let me get my handy dandy calculator out, because I'm not an arithmetic master. So 14 times 6, and we get 84 plus 84. That's not it. Okay, negative 2 times 2, that's negative 4. 3 times 14, well, that is equal to 42 plus 42. That's not it. Okay, negative 2 times 3, that's a negative 6. And, oops, this should be a 2. And then 14 times 2, well, that is 28. That sums to 22. And that doesn't work. Okay, so let's go ahead and consider some other factors then. Let's consider, let's consider 4 and 7, right? So let's say negative 4 and positive 7. Okay, 6 and 1. So 6 times 4 is 24. Sorry, 6 times negative 4 is negative 24. Plus a positive 1 times 7. That's going to give us a negative, what, 17? 17. That's going to give us a negative 17. What about the other way around? Negative 4 and 6 times 7. Well, that is going to give us 4 plus 42. That's not it. Okay, negative 4 times 2, which is negative 8. 7 times 3, which is 21. Okay, that gives us a 13. Whoops, I'm supposed to be putting S in all of these, by the way. These are all supposed to be S's. So, since we got a positive 13 on this one, we need a negative 13. We know that we can just swap the signs here and then carry this out to find out which row we need in, right? And so on this we had negative 4s, so let's try it with a negative 7s and a positive 4s. Okay, so let's see now. 2 and 3 gave us the 13 last time. Let's go with 3 and 2 this time. So 3 times negative 7s is negative 21s, right? 2 times positive 4s is 8s, and that gives us a negative 13s, which is what we wanted. Yes, victory. Okay, so these guys go away because we know which sum it belongs to. It's the 3 and 2 sum, right? So the 7s was multiplied by the 3, which means that we have to put it in the opposite binomial, 7s, right? Which means that the 4s goes in the remaining binomial, and this, whoops, don't forget our, nope, we didn't have a negative on this one, so this is our final solution. Okay, so yeah, just kind of keep in mind that those can be tedious. Let's deal with a different method. This is called the grouping method, right? The last one we did was sort of like more of a guess and check. This one is maybe a little more precise. I don't know though. So step 1, factor out the largest common factor, right? That's something that, what we mean by that is what we did in this problem, right? We factored out the 4x. Factor out any largest common factors. Multiply the leading coefficient with the constant c. Multiply the leading coefficient a with the constant c. Find a pair of factors, this should say factors, not factors, of the AC whose sum is b. Rewrite the middle term b as a sum or a difference using the factors from step 3. 5. Factor by grouping. Include any common factor from step 1 and check your answer. Okay, so from our general form here, we can use this example, right, where a is equal to 3, b is equal to -10, c is equal to -8 to kind of inform us on what we're going to do here, right? So step 2 tells us that we're multiplying a by the constant c. A is 3, c is -8, that equals 24, right? And so So let me pause real. Okay, so anyway, where was I? So we're about to list pairs of factors of -24, and we're going to look for a pair of those factors that sum to -10, right? So let's see now, -1 and 24. Nope, that sums to 23. 1 and -24. Nope, that sums to -23. 2 and 12. Let's say -12. Nope, that sums to -10. Oh, yes. Yes, we wanted -10. We found one that sums to -10. Okay, so now that we found that, we know that this is how we need to split up. This is how we need to split up our middle term, right? So this is where things get a little bit weird, right? And so we're just going to note this, right? -10x is equal to 2x minus 12x, right? And so what we're going to do, we're going to go back to our original polynomial. Let me just give us a little bit of room here. We're going to go back to our original polynomial, and we're going to rewrite it using this that we just found. All right, so 3x squared minus 10x minus 8. This is equal to 3x squared plus 2x minus 12x minus 8. Right, so we split that guy up. We've now split that guy up into two different x terms, right? We're going to take those x terms and we're going to factor by grouping using those, right? Usually when we factor by grouping, we want to combine like terms and all that, but a lot of times it's more convenient to leave them separated, right? So we can rewrite this stuff, right? So what we're going to do is we're going to factor an x out of these first guys, right? And then these second guys, we're going to factor a number as well. So we're going to say x times 3x plus 2, right? Minus, and let's see. Now we're actually going to subtract. We're actually going to factor out. We're actually going to factor out a 4, right? Because each of these contain a 4, and each contain a negative. So we're going to factor out a -4. Right? It's crucial to know that we had to factor out the negative to get rid of both of these. If we had factored out a positive, then there would be 2 negatives still contained in here. And actually, maybe just so we don't forget how to do that, maybe I'll do it that way. Just so that we're clear on what's happening here, and you guys know I'm not skipping any steps. So if we just factored out the 4, then inside we would have a -3x and a -2, right? But we want this to match this because we're factoring by grouping, so then we factor out the negative. X times 3x plus 2, and then we have a -4 times 3x plus 2. Since these factors match exactly, I can pull them out, right? And so we write 3x plus 2, right? And I've pulled it out of the x and the -4. Boom, that's our answer. Okay, and so to factor by grouping, this is, this is kind of a matter of preference as to whether you like to factor by grouping or not. To factor by grouping, we multiply a by c. We consider factors of that multiplication, and we see which ones sum to b. That informs us on which of those factors we use for our final factorization. Okay, so let's try this one more time. Let's do an example, one last example of factoring by grouping. Well, first things first, let's go ahead and factor out any commons that we have. So we have a common factor of x in everything and a common factor of 2 in everything. So we're going to factor out a 2x. That's going to leave us with 4x squared plus 11x minus, oops, that should not be a 6, that should be a 3, minus 3. Okay, so now we want to consider factoring by grouping. And so for this particular polynomial, a is equal to 4, b is equal to 11, and c is equal to negative 3. What we want to consider for our pairwise factors, what we want to consider is factors of a times c, which is negative 12. We want those factors to sum to b, which is 11. Right, okay, so let's start. So first we're going to consider negative 1 and 12. And just so you guys know, I always start out on negative 1 and 12 during, like, you know, class examples, just so that we can run through a couple columns or a couple rows before we get to the answer. But a lot of you guys will be able to see, you know, like kind of what those factors should be, and you'll be able to cut them down pretty quickly. Like for this one, we see that b's got a sum to 11, so we know that actually 1 and 12 will be good options. You know, they might be good options anyway. You know, and we'll also see that like 3 and 4 are probably not good options for this one, right? And so we'll start by considering 1 and 12, and hey, look at that. The very first one we considered after I said all that junk was summing to 11. You know, other factors like, you know, negative 3 and 4, like, you know, that would have summed to just plain 1. We can see that that wouldn't have worked, right? No matter what kind of combination we put, negative 3 or negative 4s or whatever, we're not going to get 11. So we don't, you know, so we can cut some steps out if we don't even consider those. But we did find our answer here. We did. And so and so we're going to go ahead and do a little grouping on that middle term, right? And so we're going to say 11x is equal to negative 3x plus 4. Okay, and so then we're going to rewrite our original polynomial. We're going to rewrite it as, right, not our original, but our factored, 2x, right? And then we have 4x squared minus 3x plus, oops, what did I do here? Oh, I know what I did. Right when I was telling you guys that 3x and 4x wouldn't work, I started using that. So let me just back it up here. So back it up. These were the ones that worked. So those are the ones that I need to use, right? 11x is equal to negative x plus 12x. Okay, so now we break it up. Now we have negative x plus 12x, and our constant term was negative 3. Okay, so is this going to work if we factor by grouping? I think it will, but if we just real quick consider, like, you know, we could factor a 3 out of the 12x minus 3. That would leave us with that would leave us with 4x minus 1. And actually, that might work just fine. Yeah, we're going to try that. We're going to try and group these guys like this. We're going to see what happens when we factor some stuff out. So we're going to have 2x, right? And then we're going to factor an x out of each of these. So when we factor the x out, we get x minus 1. 4x minus 1, sorry. Right? Plus, what happens when we factor a 3 out of these? Well, we get 3 on the outside, 4x minus 1. And look at that. That's exactly what we wanted, because this factor matches this factor. So we can write our final answer in the next line by saying 2x. Right? And then we have x plus 3, right? Those terms came from here, right? The 3 and the x kind of combine into their own sum after this is over with. And then we multiply all that by the 4x minus 1. Right, and so an important thing to remember is that even though we have a 4x minus 1 in both of these terms, when we factor it out, we only get one factor, right? Okay, so a big sigh after that one. This stuff can be pretty tedious. You know, that's the end of the chapter. If you guys have problems with this, assuming that we're not buried by snow tomorrow, you can come and see me in the Student Center. If we are buried by snow tomorrow, I'll be putting out lectures, and maybe I'll put out a couple example videos with this stuff, just because it's really weird and there's a lot of ins and outs. But besides that, yeah, just everybody have a good snow day, and keep paying attention, because if it snows more tonight, we'll have another video lecture tomorrow. So have a good day, guys. We'll talk to you later.